Good morning, my YouTube viewers. It's Crystal here. I wanted to make a video for you about a Kaggle competition that I entered 2 years ago, and the reason why is because I looked in my junk mail, as a matter of fact, and when I looked in my junk mail, I found out that I had won a silver medal on this competition that I entered 2 years ago. And if I hadn't looked at my junk mail, I would not have known that I had entered the competition. So, as far as I know, this is my first silver medal that I've ever won on a Kaggle competition. And I decided that under the circumstances, I wanted to make a video on it being my first silver medal. So it's the ell-nlp-multioutput competition 2 years ago. The problem statement is the goal of this competition is to assess the language proficiency of 8th to 12th grade English language learners utilizing a data set of essays written by ELLs will help to develop proficiency models that better support all students. So the first thing that we're going to do is we're going to create a Jupyter notebook, which I did. I created the Jupyter notebook, and we're going to save it into the Kaggle website, which I did. I saved it into my Kaggle account, and then we're going to do this. We're going to enter this competition. So we're going to import NumPy SMP to calculate numerical values. We're going to import pandas SPD to process data. We're going to import OS, which is the operating system, and it goes into the operating system of the program to retrieve files. We're going to import matplotlib.pyplot as PLT, which is going to visualize the data, and then we're going to import Seaborn as SNS, which is to statistically visualize the data. We're also going to import sklearn, which provides machine learning functionality. We're going to load the files using the OS, and then when we load the files using OS, we're going to get 3 CSV files back, being a sample submission, a training set, and a testing set. So we're going to read the files. So we convert the training set to train using pandas. We're going to convert the testing set to test, and we're going to convert the sample submission set to submission. So we'll do all that with pandas. So we've got our training set. We have a text ID, a full text, a cohesion syntax, vocabulary, because it's a multi-output. Excuse me, I'm just recovering from a cold. You have vocabulary, phraseology, grammar, and convention. So it's a multi-output. It's a multi-output competition. And then we have the test set, which is only 3 rows of data. And the thing about the test set with Kaggle, when Kaggle has a bona fide competition, a real competition that people can enter to win money, the test set is actually very small. And in this instance, the test set is very, very small. So you've got a test ID and you've got a full test, and you've only got 3 rows of data. So we've got the submission set, and this is what Kaggle wants to see when we submit our data. And now what we're going to do is we're going to analyze the targets. And since this is a multi-output data set, we've got lots of targets. So we're going to create a histogram of cohesion. And so this is the histogram of the cohesion. And you can see that looks close to a normal distribution, but it's a little bit skewed on the left. histogram of syntax. Again, it looks close to a normal distribution, but it is a little bit skewed on the right, or left, sorry. We create a histogram for vocabulary. Again, it looks a little bit skewed on the left. We create a histogram of phraseology. Again, that's a little bit skewed on the left. A histogram of grammar. Again, it's a bit skewed on the left. Histogram of conventions. It's skewed on the left. And now we're going to define our target. So we say features, but really it's not features. I should have said, really it's not features. I should have said columns or something like that, because the feature is what you use for your independent data. But I did this about 2 years ago, and I wouldn't say features today. I would probably say columns. But we set our features, which we know it's not features, it's columns. And target equals trained features. And then we list our target. So this is our target, which is 1, 2, 3, 4, 5, 6 outputs. So now what we're going to do is we're going to combine the train and the test. And I wouldn't do that today. Today I wouldn't combine my train and my test because I've moved on since then. But in this instance, I did my text train equals train full text, and text test equals text full text, and then text equals train text train dot append text test text. So I wouldn't do that today. I would do it differently, but that's what I was doing 2 years ago, because obviously I had to teach myself how to enter Kaggle competitions, and I had to teach myself machine learning. And so I would look at other people's work, and then whenever I looked at other people's work, I would try out their techniques, and that's how I learned how to do it. But I've moved on since then, but this is a 2-year-old competition question. So we're going to analyze the text. Word count equals text.string find all, and then string length, and then you're going to print the words. So it's 1,707,247. We're going to process and clean the text. So text equals text.string.lower, which means first thing we're going to do is we're going to import re, which re is like a text processing library. And then we're going to convert the text to lowercase. And then we're going to remove special characters. Text equals text.apply lambda x colon re.sub, and then you've got the special characters that it's going to allow. And then X is your lambda. We're going to remove hashtags. So strictly speaking, the hashtags should have been removed in the special characters, but I went ahead and removed the hashtags anyway. We're going to remove words less than 3 characters and greater than 7. Text equals text.apply lambda x, and then it's a space in between quotation marks dot join w for w in x dot split if len w is greater than 2 and len w is less than 8. We're going to count the words, and we're going to print the counted words, and we've got 1,065,764. So we got rid of some more words. So we're going to remove frequently used words, and then when you remove the frequently used words, what happens is we're going to remove everything that appears only once. So most frequent words equals pd.series bracket space dot join text dot lower dot split dot value counts, and then 25. So we're only going to show the first 25 words. But Ruby, it says lower. We really should not have needed to convert them to lowercase because they all will have been converted to lowercase in the beginning, earlier in the program. Text equals text supply, lambda, x, colon, and then a blank space between quotation marks, join word for word in x split if word not in most frequent words. So if it's not in most frequent words, then it's going to remove it. And then we print most frequently words, word count, and then you print the word count. And then so what this does is this prints you out a list of the 25 most frequent words. So the and you that they have can for, excuse me, if it's not in the most frequent words, it doesn't get put in. And so basically, anything that appears only once should be removed. Now we've got an apostrophe dictionary. So we create a dictionary so with apostrophes. So ain't means am not, are not, aren't means are not, am not. And then so we got all the apostrophes in the apostrophe dictionary. And then we print all that out. Now we're going to function to replace words in the dictionary. Def lookup dict text dictionary for word in text.split if word.lower in dictionary. If word.lower in text.split, text equals replace words. So now what we're doing is we're replacing everything in the apostrophes. And then here is a lambda function. So text equals text dot apply lambda x, look up dix, x apostrophe dict. So there what we've done is we've converted everything that is apostrophe into the full words. So now we're going to remove the rare words. So again, that's everything that is less is only one word, it's going to remove it. And then so we had it over here. It says remove frequently used words, most frequently used words. If word not in most frequently used words, print it. So we're going to delete the most frequently 25 most frequently used words in that particular function. And in this one, we're going to remove rare words. So everything that's only one word, it's going to be removed. So from collections, import counter. From iter tools, import chain. V equals text.string.split.toList. So it can convert it to a list. C equals counter, brackets chain dot from iterable V. And then text equals brackets or square brackets, blank space, dot join J for J and I if CJ is greater than 1 for I and V. Text equals PD series text. So if it's greater than if the word appears more than one time, then it will get put in the list of words. If not, it's going to be removed. For X word in enumerate text, num word equals len word dot split, and total word equals total word plus num word. And then you print the total words, and now you've only got 655,620 words. Now we're going to define our X, Y, and X test. Y is your target. X is text to the length of len train. X test equals text from the len train to end, and then we print their shapes. Now we're going to convert the text to frequency, and so we're going to be using sklearns to do that. And sklearn provides your machine learning functionality. And so the thing about when you enter a competition in Kaggle, you have to have the internet turned off. And then when you have the internet turned off, you can only use libraries that are already in Kaggle, and so loaded into Kaggle's Jupyter Notebook. If those libraries are not loaded into Kaggle's Jupyter Notebook, you can't use them. So you can make your own. You can write your own function. You can write your own function if you're good enough, and I'm sure a lot of people are good enough, but I'm not good enough because I've only been studying machine learning for a few years. But if you're good enough, you can write your own function. And then so that's what these different libraries for natural language processing are used for. And people have written these libraries themselves and then put them out on the market. Like Spacey is one such library, but you can't use Spacey in a Kaggle competition because you have to be connected to the internet to do that. So sklearn is one library that is actually imported into or installed in Kaggle's Jupyter Notebook, so I could use sklearn. So I use the features in sklearn to do that. So we're going to convert text to frequency. From sklearn.feature extraction text import tfidf vectorizer tfidf equals tfidf vectorizer stop words equals English max df equals 0.5 min df equals 0.01. And then we convert x to a list. X equals list map join x. And then x test equals np array x test to list. X test equals list map join x test. X tfidf vectorizer tfidf dot fit transform x, and x tfidf vectorizer tfidf dot transform x test. And then we print 5 of the words, and so you get the 5 words that I printed out. We check the shapes. So we've got the shapes that we're looking for x tfidf shape, x test tfidf shape, and y shape. Now we select our model. So we're going to have to use a multi-output regressor for that. Equals sklearn.multioutput import multi-output regressor. And we're going to use SVR, that's support vector regressor. From sklearn.svm import SVR. Chain equals multi-output regressor SVR. Chain.fit x tfidf y. Print chain.score x tfidf y. And so you get 86.5% accuracy. Now we predict on x test. Predictions equals chain.predict x test tfidf, and then we get our predictions, and now we prepare our submission. And so since this is a multi-output target, so the submission cohesion equals column 0, syntax equals column 1, vocabulary equals column 2, phraseology equals column 3, grammar equals column 4, conventions equals column 5. But you've got to remember that in Python the first number is 0, so there's actually 6 columns of data for the target. and then you convert your submission to a CSV file. And then what we wanted to do is we wanted to read it and convert it back to a data frame. And so you can see that this is our output. So you've got your text ID, and then you've got your 6 columns of data, which are your target. And I submitted that to Kaggle. And when I submitted it to Kaggle, I only got 56% for my private score and my best score. And 2 years later, after I changed my technique somewhat, I got a silver medal for it. So it's my very first silver medal that I'm aware of. So I thought it would be a good idea for me to make a video on my very first silver medal. So thank you so much for watching my video. If you like my video, please like and subscribe. And I look forward to making more videos of a technical subject for you in the very near future.